Now, let us proceed to step 2 of creating an enterprise-wide RHEA model. This step concentrates on defining primary keys, foreign keys, and attributes which is used in designing relational database tables. A separate table will be constructed for each valid entity in the RHEA integrated diagram in Figure 1012 discussed by the previous reporter, and such will require 18 tables explained in the following paragraphs. The first one is the 10 internal agents represented in Figure 1012 will be collapsed into a single employee table. The two external agents, the customer and supplier, will each require a separate table. The third one is the two resources, the inventory and cash, will each be in a table. The fourth one is the 8 events will require a table each. And the last one is the 5 many-to-many relations represented in the diagram will each require a linking table. Now, focusing on the main objective of this step, let us first define primary keys, foreign keys, and attributes. Primary keys and foreign keys are said to be the most basic components on which relational database theory is based. Primary keys enforce entity integrity by unique identifying entity instances. In example, each row in the table. Foreign keys, on the other hand, enforce referential integrity by completing an association between two entities. Basically, it is somewhat a primary key embedded in the related table so that two tables can be linked. Attributes, on the other hand, as discussed by previous chapters, are data items that describe an entity or the characteristic of the entity to be recorded in the table. Examples of these are presented in Table 10.1, which 18 tables are derived from the Apex database discussed previously. Now let us proceed to the rules for primary keys and attributes. The determination of primary keys and attributes comes from an understanding of each table's purpose, which results from a detailed analysis of user needs. As primary key defines the non-key attributes in the table, the database designer should select a key unique and logical enough with other keys. Such uniqueness may consider using the different kinds of numeric and alphabetic coding schemes discussed in Chapter 2, like using sequential codes in creating primary keys, the invoice numbers, check numbers, or purchase order numbers are good example of primary keys in sequential code format. Still, to create an effective primary key, advantages and disadvantages of various coding techniques must be considered, which was again discussed in detail in Chapter 2. On the other hand, some table attributes are common to all organizations and can be derived from common sense and an adherence to best practices. Other attributes are unique to specific applications and can be derived only from thorough and detailed analysis of individual user views. Each attribute assigned to a table should, however, appear directly or indirectly in one or more user views. If data stored in a table are not used in a document, report, or a calculation that is reported in some way, then it serves no purpose and should not be a part of the database. Now, let us proceed to rules for foreign keys. Foreign keys are assigned depending on the degree of association between tables. These are the one-to-one, the one-to-many, or the many-to-many. Key assignment rules for linking tables had been discussed in previous chapters, but we will briefly refresh it here. So the first one is the keys in one-to-one associations. If the events are sequential, the primary key of the first event should be the foreign key of the second event. Take as an example the primary key for the verify availability table, which is the inquiry number, is assigned as a foreign key to the take order table. However, if the events are not sequential, either entity's primary key can become the foreign key of the other table. Now, let's go to keys in one-to-many associations. In here, primary key of the entity link to many entity must be used as the foreign key in the many entity. Take as an example the primary key of the employee table, which is the employee number, has been assigned as a foreign key to the verify availability, take order, ship product, receive cash, order product, and receive product tables. Same with the primary key of supplier table, which is the supplier number, has been assigned as a foreign key to order product, receive product, and disperse tables. Disperse cash tables. Now, let us go to the keys in many-to-many association. In here, it creates a separate linking table with a composite primary key. Tables in many-to-many association cannot accept an embedded foreign key from the related table. Instead, the database designer must create a separate link table to contain the foreign keys. By inserting a link between the original tables, the many-to-many association is transformed into one-to-many associations. Take as an example the 5 linked tables presented in Table 10.1, the inventory verify link, inventory order link, inventory ship link, order product inventory link, and the record product inventory link. Now let us proceed to the last topic, which is the normalized tables. The assignment of primary keys and attributes to relational tables must always comply with the rules of normalization discussed in Chapter 9. Recall that improperly normalized tables exhibit negative operational symptoms called anomalies, including the update anomaly, the insertion anomaly, and the deletion anomaly. One or more of these anomalies will exist in tables that are not normalized the third normal form or 3NF level. These anomalies are caused by structural problems within tables known as repeating groups, partial dependencies, and transitive dependencies. Normalization involves systematically identifying and removing these dependencies from the tables under review. Tables in 3NF will be free of anomalies and will meet these two conditions. So the first one is all non-key attributes will be wholly and uniquely dependent on the primary key. The second one is none of the non-key attributes will be dependent on the other non-key attributes. Now, the database tables in Table 10.1 are in 3NF but contain only minimal attributes. Keep in mind that databases are not static. As user needs change and additional user views are developed, additional attributes and perhaps additional tables may need to be included in the database. These additions must comply with normalization rules to preserve the structural integrity of tables and avoid anomalies.